Hey everyone, I'm Michael D, and today I'm going to be talking about how to solve equivalent angles in trig ratios. Normally we use our calculators and we use the inverse sine or the inverse cos and we get our angle and we're happy and we don't worry anymore. It turns out that for each valid trig ratio, there are two possible angles. There's a couple exceptions, and I'll talk about those before the video's over, but calculators only give the first answer they find. And today I'm going to teach you how to get the second answer. I'm only going to show you the how, not the why. That's another video. We'll do that another time. But if you watch this video, you're going to know how to do it. So I'm going to make a table. Trig ratio. We have three trig ratios: sine, cos, and tan. And when you put it into a calculator, you always get your first angle. And we'll just call that for each one of them theta, theta, and theta. If I do the inverse sine of 0.5, calculator gives me the answer. If I do the inverse cos of 0.25, calculator gives me an answer. But it's not the only answer. There's a second angle. A second answer that was hidden all along. And for sine, you can always get the second answer by doing 180 minus the angle that your calculator gives you. Now, if your calculator gives you an angle and you do 180 minus that angle, also correct. For cos, it's 360 minus theta. And for tan, it is 180 plus theta. And I'm going to do some examples to show you how this works, and then I'm going to show you that little possible exception, but once you see the exception, you're going to understand exactly why it exists. Let's scroll this up, but we'll keep those equations right there so that we can still have a good look at them. Let's say we have sine 40 degrees, and you've been asked to tell me some equivalent angle that would be the exact same answer as sine of 40 degrees. To do that, we look at our equation and say we've been given 40 degrees. The second answer will be 180 minus 40 degrees. So my second answer will be sine of 140 degrees. You can go ahead and plug this into the calculator. If you do the sine of 40 degrees, it's about 0.643. But if you do the sine of 140 degrees, you're going to get the exact same answer. These are the same. If you have a theta and you do 180 minus that theta, same answer. We do the same thing with cos. If we had cos of 40 degrees, and we go ahead and we check our equation, and we can see that cos has a second angle possible. It's 360 minus theta. 360 minus 40, I picked nice numbers on purpose, you can do these, is cos of 320 degrees. Again, you can go ahead, plug this into your calculator. It's going to work out to be 0.766. True for both of them. These are equivalent expressions. One more with tan. If you've been given tan of 40 degrees and asked to come up with an equivalent expression, we go into our equation. We have theta, it's 40. 180 plus 40, which is our theta, means 220. Oh, no. We need to have a tan there. We need to have a tan there. Tan of 220 degrees. Don't forget those trig ratios. You can't just say that tan of 40 degrees equals 220 degrees. That was a good mistake, but that was worth it. Good learning moment there. I do a couple more, just as another example here, so you can see some complications that could arrive. And we're going to leave those ones on. And we're going to do this time sine of 300 degrees. Well, we can do 180 minus 300. 180 minus 300. It's going to equal negative 120. Well, that's not really helpful. If you ever get an answer that's below 0, you can add 360 to loop back around the circle and get a correct answer. Same thing is true if you get an answer above 360, you can subtract 360. So if we take this negative 120 and we want to get it back into degrees that we're used to working with, between 0 and 360. We can add 360 to this. It will equal 240 degrees, which means sine of 300 degrees is equal to the sine of 240 degrees, even though, wait for it, if you put in the sine of negative 120, it's also true. It's also true. We'll hit that another time. But yes, if you want to get your answers between 0 and 360, you'd have to add 360 to this negative value to get it back on track. If you were given cos of 300 degrees, that one's not too bad because we can do 360 minus theta. 360 minus the 300 is just the cos of 60 degrees. Again, you can double check those in your calculator, but it works out. And the tan of 300 degrees, this will give us the same little snag that sine gave us, because if we do the 180 plus 300, it equals 480 degrees. We don't want an answer above 360. If you're above 360, you can subtract 360. So we do 480 subtract 360. It's going to give us a much nicer number equal to 120. And now we have tan of 300 degrees is the exact same answer as tan of 120 degrees. You can check them out in the calculator. It's true. Before I finish off, though, I will show you the exceptions, because the exception would be something like sine of 90 degrees. If you were given the sine of 90 degrees, and you know that your second answer is going to be 180 minus theta, 180 subtract 90 is in fact 90, which would give you sine of 90 degrees equals sine of 90 degrees. If this works out that you get the exact same answer, this is an exception. Only one angle exists. Only one angle exists. So if you ever fill it in and you get the exact same answer that you just started with, that's what that means. Only one angle exists. And that, folks, is how we can solve a second equivalent angle for a trig ratio using those three little equations. Again, we didn't go through the why, but this is the how. And if you've been given one of these questions and need to get that second angle, this will help you do it. Thank you very much for watching. And if you have any questions, please leave them in the comments below. I'd be happy to take a look at them. Thank you.